Here's our last area topic, and it's going to involve some ratios and proportions. So for the moment, here are two similar rectangles, and I have three questions. Scale factor, ratio of their perimeters, ratio of their areas. So hit pause and see if you can come up with these three answers on your own. Start with the scale factor. Scale factor, we have 2 units here, 8 units here. That's a nice ratio of 1/4. And then we have the same ratio of 1/4 here. There's our scale factor. Rectangle A is 4 times smaller than rectangle B. The perimeter of A is going to come out to be 12. The perimeter of B, we can figure out, is 40. So something is not, no, that's wrong. I'm multiplying. Perimeter of A, let's try 10. That's much better. Perimeter of A is 10. 2 plus 3 is not 6. So the ratio of our perimeters is also 1/4. And if you think back to chapter 6, when we did similarity, we saw that a perimeter ratio and a scale factor were the same thing. So this is not anything new. This next part may be a little surprising. The area of rectangle A is 6. There's our 6. The area of rectangle B is 96. So when we put that in a ratio, 6 over 96, that's going to reduce into 1/16. Now, take a look at our scale factor and take a look at the area ratio. There is a relationship between 1/4 and 1/16. It's that scale factor squared. And that sort of makes sense because when we calculate area, we are taking one dimension multiplied by another dimension. So if the ratio of this dimension is 1/4 and the ratio of this dimension is 1/4, the area ratio should be 1/4 times 1/4. It should be that scale factor squared. If our scale factor was 2/3, our area ratio would be 4/9. The ratio of areas is the scale factor squared. If two shapes are similar, and by shapes we are implying two-dimensional for now. If two-dimensional shapes are similar, then the ratio of their areas is the square of their scale factor, which could also be written square of their perimeter ratio. Either one works. Whatever ratio that is, you square it, and you have the ratio of their areas. I have two examples for us to work through. Here I have some two-dimensional shape. And here I have another two-dimensional shape. They are similar. Here's value of 8, here's value of 5. I know the large area. We are looking for the small area. So my scale factor is 8/5, but that's not the ratio we use. If you do this, if you say, oh, this is 8/5 equals 112 over x, congratulations, you got the problem wrong. Because you set a scale factor equal to an area. In other words, you set a length, say inches, equal to square inches. They're not the same. They're not the same. We have to use like units here. This is a proportion, so whatever units I have here has to equal the units I have here. So I have to turn 8/5 into an area ratio. And we do that by squaring it. 8/5 squared, 64/25. That is the ratio that we will use. That is the ratio that we will use. And let me just add here, find question mark, let's say nearest 10. We'll say nearest 10. So we know how to deal with proportions at this point. I will leave the steps to you all. To the nearest 10th, we get 43.8. Square whatever units we have here. Let's give it a unit. Let's say this is square feet, so that we have square feet here. Using an area ratio to find a missing area. As long as we have a similar figure, we can solve this proportion and find this smaller area. This is not a polygon that we really have an area formula for, and we don't have really any other information to split it into triangles or other figures and find its area that way. This is really our only option. Knowing a similar figure, we can then work backwards to find this area. One more problem. An architect has created a 1/116 scale model, a 1/216 scale model of an object. The model's area is 72 square inches. What will the actual object's area be? And again, we'll go to the nearest 10th if we need to. So I need my scale factor. And that's right in the beginning of the problem. It's a 1/16 model. So every 1 unit in the model, 16 units on the real thing. We know the model's area. We need the object's area. So just to remind ourselves, model is numerator, real is denominator. I need an area ratio. I need to square my scale factor. And again, this is model on top, real thing on the bottom. I have the model's area of 72 square inches. That goes on the top. Don't know what the real area is. We are not going to need the nearest 10th. And we get that the area of the actual object, 18,432 square inches. When you're dealing with ratios of areas, make sure that if you are dealing with areas here, that you have a squared ratio here. Take the scale factor, square it to find the ratio of areas. Otherwise, you are not setting like things equal to each other.